Welcome, my friends. In this video, I'll be discussing section 4.2, simple random sampling. So let's first talk about why we even sample in the first place. Now you may remember the distinction between a sample and a census. A census is when you gather data from every single member of your population of interest. So remember, you as a researcher are going to determine what your population is. The population is just the group of all individuals that you would like to study. So your population might be maybe all adults that are of a certain age, or maybe it is a certain type of animal, or maybe it is students in a school or something like that, right? So whatever you're trying to study, that's going to be your population. And a census would be gathering data from every single member of that population. But as we've said previously, populations are typically very, very large. They can sometimes contain thousands or even millions of individuals. So in most cases, it's going to be impossible or very, very difficult to gather a census. So in most cases, researchers are going to be settling for a sample, a subset of the population, and hoping that their sample is somehow representative of the population, which really just means it's the same as the population, just kind of a smaller group. So an example that we're going to kind of work with here is, let's say we want to know what % of voters are going to vote for Ronald Crump in an upcoming election. So here we have Ronald Crump over here on the bottom right, and let's say that he is running for president of the United States. And we're like a polling organization, and we want to know what % of all the voters out there who are going to turn out for this upcoming election, what % of those voters are going to vote for Ronald Crump, and we want to estimate that before the election actually happens, right? So our population in this case would be all voters, or all the people who eventually will come out and turn out for this election, right? And there's going to be a lot of voters, so it's going to be pretty difficult to track down all of the voters and ask them who they're planning to vote for in this election, right? So tracking down every single voter and gathering that information, that would be a census, which I guess in a way is what happens on election day. Like on election day, all the voters come together and they cast their vote, and then we really have the census of all of them. But I guess the point here is we want to be able to predict what that outcome would be ahead of time. Can we know a month ahead of time kind of what's it looking like? Is it looking good for Ronald Crump or good for his opponent? We want to know that, right? So instead of taking a census, we're probably going to be taking some sort of sample from the voters. So we're not going to have every single voter. We're going to have a sample of maybe 1,000 voters or a couple thousand voters. And from that, we would hopefully be able to glean what % approximately are going to vote for Ronald Crump in this election. So the term that they typically use is, we would say that we want that our sample to be representative of the population. And I think I used this term a second ago. Basically, all that means is it's going to be basically the same as the entire population, but a smaller version of that, right? So if there are 1 million voters in the entire population that are going to vote in this election, or maybe more than 1 million, and let's say 50% were going to vote for Ronald Crump, then we would also hope that 50% of the voters in our sample would vote for Ronald Crump. That's what it would mean to have a representative sample. So let's go ahead and consider a few different ways we could sample 100 voters. And for each of these different cases, we're going to think about whether or not the sample is going to accurately represent the population of all voters. So method number one would be maybe we could interview voters outside of a Ronald Crump rally. So we could just go right outside the rally and just grab 100 of these random people, and then we'll ask them who are they supporting in the election. Well, clearly there's going to be an issue here. They're going to be much more likely to support Ronald Crump than his opponent, Mo Sidon. So if we interview people here, we're not going to get the same percentage in our sample that we would based on the entire population. That's what we mean by representative, right? We should have an equal chance to get a Ronald Crump supporter in the sample that we would in the population of all voters. And that's certainly not going to be the case here. We're going to be much more likely to get the supporters of Ronald in this method. So this is probably not the best idea. So then maybe an alternative would be to interview registered voters by phone, right? So if we want to get a representative sample of the people who are going to eventually vote, maybe we can interview people who are registered to vote, and we can contact them by phone, right? And this definitely seems like a big improvement from our previous sampling method, but there could still be some possible issues with this, right? So some voters might not respond to phone messages, or maybe some certain voters don't even have a phone. Or it could be the case that, maybe supporters of Ronald Crump are more or less likely than your average voter to respond to a phone message, right? So we may get an overrepresentation of a certain type of voter due to this kind of method of sampling. Or maybe, some of the registered voters might actually not even vote. So we may be interviewing some registered voters who might not even eventually turn out to vote. So there could still be some issues with this, but nevertheless, seems to be a big improvement from the very first method. Or maybe a third option here would be just like kind of a variety of different techniques here. So maybe we include some phone, some mail, some social media, and maybe some other different methods to target a number of different voters, right? So certainly we would be getting closer to a representative sample, but you can start to see here by all the things that we've considered with just these just trying to get a simple sample of 100 voters, how difficult it can really be to get a representative sample. So the ideal case, and sometimes called the gold standard, would be what is called a random sample, sometimes called a simple random sample. And really all that means is there's an equal chance to choose any member of your population in your sample. And that applies to every single member that you choose. So for example, let's say there are 1 million individuals in your population of interest, right? And you're going to sample the first person. Well, all of the 1 million individuals should have a 1 out of 1 million chance to be chosen as the first person from the sample. And then the second person that you choose should still be a 1 out of 1 million chance to choose any of those individuals in the sample for the second person, or the third person, or the fourth person. So every single person you choose should have a 1 in 1 million chance to be sampled. Technically, if you want to be technical here, that does mean you could have repeats. But generally that doesn't happen because, the populations are large. What's the chance you're really going to choose the same person twice, right? Pretty low. So what I want you to have in your head for random sample just means out of everyone in the population, there's an equal chance to choose anyone. And you would expect that a random sample would probably be representative, right? Representative means like, if 50% of people were going to support Ronald Crump in the election or vote for Ronald Crump, then based on our sample, we would also get 50%. So random samples are expected to be representative or close to representative, but because they are random, they could be, a little bit off, a little bit above or below that actual value, but nevertheless, since it is random, this is kind of the gold standard. This is what we would like to have in every case. But we're not always going to have that case. In many cases, it's going to be unrealistic to get a random sample. It's very difficult to really even know where all those individuals are or how to contact every single person in the population. So in many cases, you might have some sort of convenience sample. And convenience sample just says, well, don't really go out there and put all this effort forward to try to get an equal chance to choose everyone to get a random sample. Just use the data that's readily available or easy to obtain. And sometimes that can be sufficient. So convenience samples are probably not going to be random, right? Probably not going to have an equal chance to choose anyone in your population. But depending on the variable that you've collected, it might still be representative. I'm going to give you 2 examples here. One where we have a convenience sample that is representative of the population, or most likely is, and one example where it is not. So here's example number 1. Let's say our population of interest is all Grand Rapids Community College students. So we want to, for our sample, to have a representative sample, we would want to have, for whatever variable we're going to collect, which in this case is going to be number of pets owned, we would want that from our sample, however many pets were owned on average from our sample should also apply to the population. And let's say that our sample is 10 calculus students. So maybe this is a teacher who's conducting this sample, and the most convenient thing for him to do would be to just sample students from his own class, and he teaches calculus, right? And you'd probably think about this for a second and say, is this going to be a representative sample? Well, first of all, it's not a random sample, definitely not a random sample because we're only choosing students in a particular class, right? Calculus. Right? So we're not going to get students who are not in a calculus class. But is that really an issue for this variable? Really, the question you got to ask yourself is, are students in a calculus class more or less likely to own pets than your typical GRCC student? And probably your answer to that question is no, right? So this is probably going to be a representative sample because being a calculus student or being any other type of student, that's probably not going to influence how many pets you own. If you're a calculus student or if you're not a calculus student, you're probably just as likely to own so many pets as any random student in the college. So even though this is not a random sample, we're only selecting a certain type of student, the way that we've biased the results probably does not matter for this variable of pets owned. So therefore, we would say this is probably still going to be a representative sample. On the other hand, let's say that we have the same population of all GRCC students, but now the variable we're going to collect is the student's major, right? So now we're going to have a problem. If we use the exact same sample, if we still sample calculus students and we collect their major, well, this is going to be skewed towards the majors that people who take calculus have, right? So this is going to be skewed towards like math majors or engineering majors or statistics majors or anything like that, right? So this is probably not going to be a representative sample for this variable. So here you can see in two different the exact same population, the exact same sample, but depending on the variable, we may or may not have a representative sample, right? If we have a variable like number of pets owned, well, it probably doesn't matter if they're a calc student or not, right? But if we're trying to collect their class major, well, then that's probably going to make a difference, right? Calculus students are going to be more likely to have a certain major. So really the question you always had to ask yourself with convenience samples is, first of all, how has my convenience sample biased my results? In this case, it's biased it towards calculus students. And then you have to ask yourself, does the way that it's biased the results make any difference for the variable I've collected? And if my variable is pet zone, probably not. If my variable is class major, then definitely. Okay, so here is one for you to try. I want you to go ahead and decide if each situation below represents a random or a convenience sample. For a convenience sample, we have kind of those two different cases. Sometimes the convenience sample could be representative of the population, and sometimes it might not. So make that determination for each of these. So we kind of have three choices here, either random, convenience and representative, or convenience and not representative. So here are the three different questions here. So I'll give you a minute to kind of think about these and try these out, and then I will discuss the first two. And if you are a student in one of my classes, you'll have to submit an answer for the last one. All right, so hopefully you've given these a shot, and I'm going to go through the first two right now. So the first one says, a hospital has records of patients kept in folders alphabetized by last name. A nurse pulls out the first 50 folders to determine what proportion have high blood pressure. So first of all, we do not have a random sample. We don't have an equal chance to choose any of the patients at the hospital, since we're choosing the first 50 in the folder, and the folder is alphabetized by last name. So it's going to be some sort of convenience sample. So if it's a convenience sample, the next question we have to ask is, how have we biased the results? Well, in this case, we've biased the results towards individuals who are earlier in the alphabet, right? Earlier in terms of their last name. So we're going to get people whose last name probably end with A or start with A or maybe B. Now the question is that going to have any effect on, or does that matter for the variable of proportion of individuals who have high blood pressure? Or in other words, do people who are earlier in the alphabet have different blood pressure than the average patient in this hospital? And probably the answer is going to be no, right? We're probably going to have just as many people with high blood pressure from our sample that we would have from a random sample. So for that reason, I'm going to say this is probably a convenience sample that would be representative of the population. Question 2 says, a biology professor uses her class of 50 master's level biology majors to determine if memory in college students is affected by background noise levels. So again, this is going to be a convenient sample because we're not selecting from every individual in the college. I guess if we assume that was the population, all students at the college, we're only selecting students in a particular class, right? These master's level biology majors in this professor's class. So it's going to be a convenient sample. And we biased this specifically towards master's level biology majors. And I would probably wager for the variable of, their memory retention based on background noise levels, they're probably not going to be a representative sample, right? If they're master's level students, they're probably going to have maybe better study or, focus skills than your average student, right? So these students are probably going to do better maybe on this memory test than your average student. So for that reason, we would say this is a convenient sample that is not representative of the sample or of the population. All right, that's all I had to talk about in this video, so I will see you in the next one.